Okay, now we are going to speak how an image is formed for a convex mirror. Let this be our convex mirror, and this is the principal axis. The convex mirror, we are having an object over here. Let's have an object. I'm naming it as AB. It's placed in front of the convex mirror, and the image formation. We have to speak about the image formation. Then, for speaking about the image formation, let me draw a ray like this. That is, a ray is traveling like this. And assume that this ray is trying to move towards its center of curvature. Let's say we are having the center of curvature of this mirror, and this ray is trying to move towards the center of curvature. And what will happen to a light ray if it is trying to move towards the center of curvature? It will bounce back. Therefore, we will have this ray will bounce back like this. And if I am extending it backwards, it will try to move towards the center of curvature. Okay, then next we are having a light ray which is passing like this. This light ray is parallel to the principal axis. If it is parallel to the principal axis, and this is a convex mirror is diverging mirror, it will diverge this light ray. The diverged light ray will be diverging in a fashion like this. Let me draw it like this. It will diverge away like this, and if we are extending back this light ray, if it is extended back, we will have it converging over here, and the light ray will diverge away from the focus. Therefore, this point is our focus. Then this is the intersecting point, and at that intersecting point we will get an inverted image, or it's not an inverted image, it's an erect and virtual image like this. Can you see it? We'll get an erect and virtual image like this. I'll call it as A dash B dash. This is our image formation, and this image is erect, virtual, and you could see it as diminished also. What is this distance? It is the distance from object to the pole. Distance from object to the pole is object distance u. And what is this distance? Let me mark it with blue. This distance, it is the distance from image to the pole, that is image distance v. And what is this distance? This distance is distance from pole to center of curvature, that is radius of curvature r. Okay, now we are going to draw the ray diagram of object at C in front of a concave mirror. Therefore, we are drawing a concave mirror like this. This is the pole of the concave mirror. Let me mark the center of curvature over here. Between center of curvature and pole, we will have a focus. Then we are placing an object AB over here. It is placed at C. If it is placed at C, we have to draw the image formation. For drawing the image formation, let's initially draw a ray which is starting from the object passing through the focus. A ray which is starting from the object and it is passing through the focus like this, and it will emerge out parallel. It will emerge out parallel like this. This is our first ray which is passing through the focus. It is emerging out parallel like this. Then next we are going to draw a ray like this. This is a ray parallel to the principal axis, and it should pass through the focus, and if it is passing through the focus, it will pass like this, and it will pass through the focus like this, and it will intersect at this point, and at the intersecting point we will have an image which is like this, and you could see this image. I am calling it as A dash B dash. This image is real, inverted and same size. Real, inverted and same size. So object is placed at C, the image will be also found at C itself. If the object is placed between F and 2F in front of a convex lens, the ray diagram, we are placing an object. The object is AB. It is placed between F and 2F in front of a convex lens. Then initially a light ray parallel to the principal axis. The light ray parallel to principal axis will get converged and it will pass through the focus like this. Then next we could consider a light ray to the optic center of the lens. A light ray which is incidenting towards the optic center of the lens, it will pass without any deviation, and now in this session we are going to discuss about the ray diagram of the image formation in front of a convex lens. For that, let's draw a convex lens. This is our convex lens, and let me draw the principal axis, and let's mark a point F over here, and this point I am marking it as 2F. Now we are having an object placed over here. This is our object AB. Where is this object placed? This object is placed between F and 2F. We have to find out the image formed in the case of this object. For that, let's take a light ray which is starting from the head of the object and it is passing through the optic center. A light ray which is starting from the head of the object, passing through the optic center, it will pass like this. It will pass without any deviation. A light ray which is passing through the optic center will pass without any deviation. Next, we are taking a light ray parallel to the principal axis. This is the light ray which is parallel to the principal axis, and it should pass through the focus. If we are having a focus over here, this lens will have a focus at the opposite side also. Let me mark the focus over here. Okay, then the light ray will pass through the focus like this. Let me put the focus over here. It will pass through the focus like this, and as a result of it, the two light rays are getting converged over here. By extending the principal axis, we could see an image is formed over here. The image is A dash B dash. If this distance is F, I could say this distance will be 2F. The image is formed beyond 2F. Can you say the nature of image? The image is inverted, real and magnified. What is this distance? This distance is U. This distance is V. And this distance is F. Okay. Next, now we are going to see the image formation in the case of a convex lens, and in this case let's mark this point as optic center. This is our focus, this is our 2f, twice the focus. Now we are placing an object over here. This is our object AB. It is placed beyond 2f. We have to locate the position of image. In order to locate the position of image, let me draw a straight line like this. Initially, this line is passing parallel to the principal axis and it should pass through the focus. If this is the focal length and at the equal distance we will have a focus, let me mark it over here, then the light ray will pass through the focus. It will pass through the focus like this, parallel to principal axis, passing through the focus. Then we could take another light ray which is starting from the head of object and it is inciding over to the optic center. Light ray starting from head of the object and it is inciding over to the optic center like this. A light ray which is inciding to the optic center, it will pass without any deviation. Therefore, it should pass without any deviation like this. And we will have an intersecting point over here. If this is F, at the 2f distance, it should be somewhere over here, 2f. And at the intersecting point, we will have an image like this. That image is inverted, diminished and real. This is our image A dash. Okay, this is our convex lens and this is the principal axis of convex lens. We are having optic center over here. Let's mark the focus over here and this is the 2f position. Our task is to find out the ray diagram or the position of image for a object AB which is placed between optic center and focus. For that, initially we are having a light ray which is starting from the head of the object and passing through the optic center. It is passing like this. It's passing like this. Then we will have another light ray which is passing like this. That means this light ray, it is parallel to the principal axis. It should pass through the focus. Let me mark the focus at an equal distance somewhere over here. Then the light ray, it will pass through the focus like this. Analyzing these two light rays, they are diverging light rays. Therefore, they won't converge at this point. We will have to extend back these two light rays. The initial light ray is extended back like this. The second light ray, it is also extended back like this. The two light rays are, I'll make a little bit more darker. The two light rays are tending to converge at a common point, and at this common point we will get an image of that object, and I'm making it as a dotted line. That is because the image is virtual, erect and magnified, and A dash P dash is our image. Therefore, what's this distance? Image distance V. This distance is object distance U, and this distance is focal length F. Hi friends, today in this video we are going to see the image formation of an object in front of a concave mirror, and you can see this is the ray diagram for object beyond C. If the object is placed beyond C, for that we are having a concave mirror. Let me mark this point as pole, and it will have a center of curvature. It is the center of the sphere this concave mirror is a part of, and between the center of curvature and pole we will have our focus. In this case the object is placed beyond C, therefore we are placing an object AB which is beyond C. Then by ray diagram method, initially I am considering a light ray which is passing parallel to the principal axis. A light ray which is parallel to the principal axis, it will pass through the focus. Therefore this is how the light ray which is parallel to principal axis will pass. Then next we could take a light ray which is starting from the head of the object passing through the center of curvature. Then this is the light ray which is starting from the head of object and passing through the center of curvature. A light ray which is passing through the center of curvature will bounce back, therefore it will retrace its path, bounce back. It will bounce back like this, and at the intersecting point over here we will obtain an image. That image is A dash, B dash. The nature of images: real, inverted and diminished. The image is formed between C and F. Next, let's draw the ray diagram for object between F and P. Object is placed between F and P. For drawing the ray diagram, this is our pole. This is our, let's mark this point as our center of curvature. Between center of curvature and pole we will have our F, and now we have to place our object between F and P. That is, this is our object and I am marking it as AB. If this is our object, initially I am taking a ray which is passing parallel to principal axis. A light ray which is passing parallel to principal axis should pass through the focus. Therefore it will pass through the focus like this. And next I am taking a light ray which is starting from the center of curvature and touching the head of the object. A light ray starting from center of curvature, it is touching the head of the object. It will move and fall over the mirror like this. A light ray which is passing through the center of curvature will retrace its path, therefore it will bounce back like this. These two light rays are diverging rays. Therefore, if I am extending back the two rays, if this ray is extended back, I could draw a dotted line like this. It will move like this. And if this ray is extended back, I could extend it like this and it will move like this. And if we are extending this principal axis like this, this is the intersecting point. At this intersecting point we will get an inverted, not an inverted image, an erect image like this, and I will call it as A dash, B dash. Then if we are marking all the distances, this distance is the distance between center of curvature and pole. It is our radius of curvature. This distance is the distance between object and pole. It is object distance. And this distance, it is the distance from image to the pole, and this is image distance V. Then next is the ray diagram for object at F. For that, this is our pole. Let's draw our center of curvature over here. Between center of curvature and pole we will have our focus. Now we have to place our object at F. If we are placing our object at F, we will get, let's draw the ray diagram. First we are drawing a light ray which is parallel to principal axis, it should pass through the focus and it will pass like this. Then if we are drawing another ray which is starting from the center of curvature and touching the head of the object, it will move like this, it will move like this, and it will fall over the mirror over there, and it will bounce back, and it will bounce back like this. You could see these two rays are parallel rays, therefore they will try to converge at infinity. Therefore the image will be formed at infinity if the object is placed at f. The image will be formed at infinity.